Hey guys, welcome back to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2006, 10A, Problem 16, and it deals with geometry. I hope you all enjoy this video and let's get started. States a circle of radius 1 is tangent to a circle of radius 2. The sides of triangle ABC are tangent to the circles as shown, and the sides AB and AC are congruent. What is the area of triangle ABC? Okay, so here we have the triangle, and the radius of each circle would be 1 and 2 correspondingly. So it would be, this would also be 1, and then this would also be 2. So to figure out the area of a triangle, we can use the area of a triangle formula, which is 1/2 times base times height. Well, the base would be BC, and then the height would be this line right here. It runs all the way down. And I'm just going to name this point, we'll just call it F for now. And so right now we don't know what BC is, and we also don't know how long this segment is. So we can start off by drawing a perpendicular line from the center of these circles to AC. And so these would form right angles. And basically what I'm trying to do is I'm trying to make similar triangles so we can use proportions. And so we see here that I'm just going to name this point E and this point D. Okay, so we have triangle A, E, and okay, so now that I have all the points labeled, we see that triangle AO1E and then triangle AO2 and D, these two triangles are similar, and so we can use proportions. So we know that AO1, which is this segment right here, over AO2, which is the entire segment all the way down to 2 here, is equal to EO1 over DO2. So it'd be this line over this line. And while we know some of the segments, because we know that EO1 is equal to 1, and then DO2 is equal to 2. And then we'll just keep AO1 for now because we don't know how long that is. But then we can express AO2 using AO1. So that way we only have one variable. AO2, which is the entire segment, is equal to AO1 plus this segment right here. And that segment is 3 because, as I said, this part's 1, this part's 2. So it would be AO1 plus 3. And then we can cross multiply. So we would get 2AO1 is equal to AO1 plus 3. And then moving this over, we get AO1 is equal to 3. So now that we know AO1, we can find out AF. And so AF would be AO1, which is 3, plus 1 plus 2 plus 2, which is 8. So now we want to find BC. Well, we can start off by again using proportions, but this time instead of using the triangles AO1 and E and AO2 and D, we can use AO1 and E and then AF and C. But keep in mind that it's not just this line over this entire line over is equal to this over this, okay? And I'm going to erase some so we can see it clearer. Okay, so we see here that this is a right angle. So for triangle AFC, the right angle lays at angle F. But then for triangle AO1 and E, the right triangle lays at angle E. And so the proportions will only work if we do AE over AF. Because you can kind of think of it like this. So we need to flip the triangle A of E and F over, which would essentially look something like this. And so this triangle would match up to the big triangle AFC, which I'm just gonna draw it again over here, which looked something like this. Actually, let me draw a little bigger. And so now we see that AE would match up with AF, and then EO1 would match up with FC. And then this would be equal to, as I just said, EO1 over FC. And looking at this, we also know some of the values. We know that AF, which we just solved for, is 8. And then EO1 is 1. And then FC is what we are trying to solve for. But the problem here is that we also don't know AE. But we can use Pythagorean theorem to figure that out because we know the other two sides of that triangle. So it would be EO1 squared plus AE squared is equal to AO1 squared. And we know that EO1 is 1. So that'd be 1 squared. And then AE squared is equal to 3 squared. And so solving for AE, it would give us 2 radical 2. And then we can substitute 2 radical 2 into this equation, which would be 2 radical 2 over 8 is equal to 1 over FC. FC. And then this would simplify to that. So cross multiply once again. FC times radical 2 is equal to 4. FC would equal to 2 radical 2. And so now we know that this line is 2 radical 2. To find out the whole entire line, which is the base of the big triangle ABC, it would be multiply that by 2, which would be 4 radical 2. And then we can just plug it into the triangle area formula, which would give us 1/2 times 4 radical 2 times 8, which is 16 radical 2. And so the answer would be D, 16 radical 2.